Hi, this is Mr. Yeager. I just want to do a couple problems, basically these wave problems that involve like radar and sonar, kind of the idea of reflection going on too. You got a few of these during this unit as well. And some people get them confused thinking they have to try to find, using the wave equation, velocity equals frequency times wavelength, or wavelength times frequency. It turns out these problems are actually more involved using this velocity is just simply distance over time, and it's more of people get confused on what is happening during the problem. And I mean, once we kind of go through it a couple times, hopefully we'll see they're not overly difficult. You just kind of have to go, okay, what is it trying to tell me? What does it mean? What does the time represent, and everything else like that. So I have two problems to do. You can see the first one here. This is at the end of the wave lecture that I didn't cover in the video. If you send a submarine, well, that's already poor English. Uh, let's just say if a submarine sends a signal at 300. If a submarine sends a signal at 340 meters per second out and it bounces back in 4 seconds, how far away is the ship it's detecting? Okay. So what we're looking at here is basically you have this submarine, okay, and there's a ship. Maybe it's right on the surface trying to detect. All right. There's my wonderful drawings of submarine and a ship. And basically what happens is a signal is sent out, hits the ship. The thing is, it bounces back, it hits the ship and bounces back to the submarine. All right. And we want to go, how far away is the ship? What's the distance? Well, what we got to watch out for is, what are we given? We're given that the signal is going to go 340 meters per second. So velocity is 340 meters per second. Okay. And we're given a time, 4 seconds. Well, what is this 4 seconds? That's the time for the signal to go out and back. So the whole trip there and back takes 4 seconds. So you got to watch out. There's obviously two ways that there are ways to solve this. We only want to find the distance out, going there. We don't need the distance there and back. Then we've doubled the distance, and that's not the right answer. So instead, the thing is, sound's going to travel one velocity when it's in the same medium. It'll travel one velocity as long as it stays within one medium. And so what we can say is it'll take 2 seconds for the signal to go out and 2 seconds to come back. It should be that way. And we're not going to do problems where the boat's getting farther away and so forth. These aren't Doppler problems. They get much more complicated if we do that. This is where the object is still. So 2 seconds out, 2 seconds back, which means what's the distance out? It's going to take 2 seconds for a wave traveling 340 meters per second to reach its destination. So here we go. V equals d over t. 340 equals distance to the boat over 2 seconds. Multiply times 2. The boat is 680 meters away. 680 meters away. Now, some people do this and they go, well, let me find the total distance. I can do 340 equals distance over time, the total distance there and back, and to put in 4 seconds there. Obviously, what is that? That'll be 1360. All right, yep, 1360 meters. But again, divide that by 2, because that's the distance there and back, and we still get 680. All right, so I prefer the first method I showed you. All right, basically cutting it in half and figuring it out from there, rather than looking there and back and then cutting it in half. All right, so that's how you kind of focus on these particular problems. All right, I think I have one more. You shout at a mountain that is 1,000 meters away and your voice travels at 760 meters per second. How long will it take for you to hear the echo? All right, so here you are. Here's the mountain. You're yelling at it. It made you mad. Okay, so you yell at it. You don't hear it when your voice. You don't hear your voice when it's over at the mountain. You're not there. It has to travel on back. Okay, so for this one, it's kind of strange. I actually like to double the distance here. It's 1,000 meters out and 1,000 meters back that my voice traveled at 760 meters per second. And so therefore, my total distance is 2,000 meters that it traveled, because I'm saying how long will it take it for it to go there and for it to bounce back and for me to hear it. So I do 760 equals 2,000 divided by t. Time will equal 2,000 divided by 760. And it will take me, let me get my calculator, a little over 2 seconds to hear that sound. 2.6 seconds. I'll hear my echo after 2.6 seconds. All right. Again, you could have solved for the time there and then multiplied it by 2. I like to try to usually solve for it right away by playing with the numbers at the beginning rather than at the end. All right. It doesn't matter. You know, you choose which method you want to use with it, but you have some definitely quite a few problems to try it out. Just to quickly go over some things. Okay. One more time, frequency is equal to the inverse of the period. All right, you're going to have plenty of problems that you're going to practice where you're given period or frequency. Remember, frequency is equal to waves over time. All right, period is equal to time over waves. So you might get a very simple question. I'm not trying to make it difficult on you. All right, where I'm just saying 30 waves pass in 5 seconds. What's the frequency? 30 divided by 5 is 6 hertz. All right. Sometimes on some of the problems I give you for your assignment, people, they just overthink the problem. They think it's way more difficult, and sometimes just they don't know what frequency means. You need to know your terms well. All right. Understand, they might talk about, you might use velocity equals distance over time. If they say the wave travels a total distance, of 5 meters. So you might have to plug in that for distance. That's different from wavelength. They'll be pretty specific in the problems. Wavelength, again, it's the definition. Are they saying this is the distance between two crests? This is the distance of one whole wave. The wording is trying to be as clear as possible when they want you to say, that 5 meters is a wavelength or is it a distance? Is it measuring the distance between two waves? Is it measuring the distance that it travels? So again, just read carefully, and I don't think you're going to have much problem with these problems. They're pretty straightforward. All right, so that's about it. Thank you.